Hi, hello everyone. So this lesson is on our neural network and we'll use the FashionMNIST dataset. So before I start, I'd like to tell you what is FashionMNIST dataset. So I have given this URL. So FashionMNIST dataset is a dataset of some article from Zalando consisting of a training set of about 60,000 examples. So there are 60,000 images with labels and there are 10,000 for to test whether we will use this for testing purpose, whether our model is correct or not. And all the images are grayscale and has size 28 by 28. So we have pixel values 28 by 28 is 784 pixel values. So we'll use these pixel values to predict the classes of the images, and the classes are, these are the classes. There are 10 classes and we'll use a neural network for this one. And this video is divided into three parts. The first part is the download dataset, how to download this dataset, and in this part we will do the create loader also, that how to create if when you have downloaded, then you will create a data loader so that you can load the data at the time of training. And before we start the training, we'll use we'll see some sample images also. In part 2 we'll create a neural network, and in part 3 we'll do the training. Okay, so this lesson is only for the part 1. In that we will download data loader and show sample images. So these are the labels I have just copied from the GitHub repository, that these are the labels 0 to 9. And I've also included some of the libraries that we'll be using, matplotlib inline, so that we can display all the graphs or images inside the Jupyter notebook, and then matplotlib.pyplot to display the graphs, import torch.network NN module, neural network module, torch vision, dot transforms, in order to convert the images to the tensors and apply some in case we want some transformations on the images. Model summary, wherein we will use to when we'll create the model neural network, so we can see what's this, how many layers are there, how many parameters are there. We'll talk at this one in the second lesson. And then numpy pathlib is to get the home directory, and OS to join the part, tqdem to get the progress bar. Okay, so in the part 1, our objective is to download the dataset, create data loader, show sample images. We'll write 3 functions for this one. Our first function will be to get a project directory. So the objective behind this one is that we have some project directory wherein we can store the data and we can store the result. So I'll just name this function as get project directory, and in this one we'll pass the some project. For example, if we are working on FashionMNIST dataset, so we'll pass the FashionMNIST dataset. Otherwise we'll pass the some other name, whatever, whichever dataset we want. So this is by default, it will be FashionMNIST dataset. Okay, so this will return us this should return us a home directory, the home where I want to store the data set. So generally what I do is this repository in my Dropbox, so that it can be synced easily on the Linux and other machines, and the data set or models I save in the home directory at the root or maybe in C drive if it is Windows. Okay, so this is a home, and it will also return us the models path. So where do we want to store the models, because models are also heavy files, so we don't want to store in the Dropbox or cloud. Okay, so these are that's the objective of the get project directory. So in order to get the home directory path, because when you are working on a different machine, so each path is different, so it's best to use the pathlib directory, file library. So we can use the pathlib and dot path and then home. So this will give you, irrespective of the machine, we will get the home directory. And in this home directory we can create a folder with name project. If it is a FashionMNIST, so a FashionMNIST folder will be created. If it's a CFR folder, CFR project, so then the CFR project will, so that all of the models and data set remain in that folder. Okay, for the directory. So what we can do is we can say os.path.join, and we'll write the home, So this is a home path we have already given, and then what we want is I can create the data sets. So all of this will the datasets folder will be created, and maybe just another subfolder if you want to create, and then project, whatever your project is. So we want to create this inside the home. I want to create a datasets folder, I want to create n folder, and then project folder. In order to create the folder, you can use the os.makeDirs. So makeDirs will create this home in case if, but it may show you an error if this already exists. So what you can do is, in order to do that, you can say exist okay is equal to true. It will not show an error, and it will create all of the folder and subfolder automatically. So this is our home directory. So we got home directory, and next is our the models path. So models path will be equal to, what I want is that in this home directory I want to have one more folder called models, just wherein we can save the our models. os dot path dot join, and then home, and then here we want to have models. So this is our model directory, and similarly we need to create this models path also, and we can use again the same function os.makeDirs, and then now this time we want to create the models path, and exist okay is equal to true. In case it exists, no problem error. So this function will return us the home directory and the models path. So we can try it. Yeah, these two paths are getting returned. Home, we have the home manager datasets, and it will be your username. I'm using the Mac machine. Okay. Accordingly, you will get these paths. So, and FashionMNIST, and then FashionMNIST model. So we have home, and our next task is to create a loader. So I'll write a function called create loader. So create loader will do two tasks. So it will take your it will download the dataset, and as well as will create a loader function for that. We'll see what do you mean by loader and downloading. But in order to create a loader, because we need to load all of the images, and most of the time you will see the dataset is huge actually, and you may not have that kind of memory. Your memory may be 16 GB or 32 GB, but your dataset may be of 3 GB, sometime 500 GB or more than even you may be working on TBs also, depending on which problem you are going to work. But definitely the RAM size is not that sufficient. So what you do is we create a batches. So one batch at a time is loaded. That's the function of the data loader. So we want to create a data loader, so that, for example, you want to load some 64 images only or 32 images only, depending on the model size. Also sometimes the network is large, so we need to have a we may not load even 64 images. We will need to load 32 images only, and depending on the GPU memory as well. So we need to take care of all of those things. So in create loader, we need to tell that how many batches, how many images in one batch we want to load during the training. So we'll say batch size is equal, because this is a 32 28 by 28, so it's not a big data set. So we can say that depending on you can increase depending on your system memory and GPU memory. You can set it to 64, maybe 128, maybe 256, depending on your system. Okay, so I'm just using it for 64. So this is the batch size we'll take, and now is our task first to download the dataset, and after downloading the dataset, we will create the loader. So, and in order to do download, we will download two datasets, as we saw that this FashionMNIST gave us two types of data: training, which is of 60,000 images, and the test dataset, which is of the 10,000 images. So we'll write here that train data. So this is the train data, and we can use all of the datasets are available in the Torch Vision library, and in that you will call torchvision.datasets. And then if you click dot, and then you will see that if you want to check with this, with FashionMNIST dataset is here, so many datasets. So I think MNIST also here, Caltech, C for 10, 100. So you just need to select which dataset you want. There are so many datasets directly available from the Torch Vision library. Okay, so we need a FashionMNIST dataset. So that's the FashionMNIST dataset. And now in this one, if you see this its signature, so you need to pass the root, you need to tell whether the training is true or not, and then transforms, and that target transforms, and download is equal to true or not. Okay, so these are the four parameters that you need to tell. So first is, for example, we need to tell that where do we want to download. So root. So root was the first parameter that we want to give, and that's why we created our project get project directory, that we will pass this home directory to the. And what we can do is we can save this path into here, that is home and models path. We got it. So now we can pass it to the home, so that root is equal to home. So all of the data files related to the FashionMNIST dataset will be downloaded into this home directory. And then we need to tell that train is equal to true. So we have created this variable as train data. So we want to store 60,000 examples here in the train data. When train is equal to true, for testing we'll just say train is equal to false. And then we will say the download is equal to true. So download equal to true means needs to be downloaded, but it will not if there is the dataset already existing in this folder, which is the home directory, so it will not download. And next is that we want to convert these images to the tensor. So for this purpose, for this lesson, we are just using the default transforms that we need to pass this parameter first. Transform is equal to, so we will just use this transforms torch vision or transforms and the to tensor. So in future lesson we will use more functionality of this one, that we might resize, we may do some data augmentation using these transformations. Okay, so this is what all is about to train dataset. And now what we need to do is we can create a similar kind of structure for our test dataset. And the changes here will be that it's still home, it is still train is now false, because this is test, so we can just say train is equal to false, so it will give us the 10,000 example. Rest all will remain same. Okay, so now we are done with train and test data. So if everything is working fine, so we will get these data sets, train and test. So next is to create the data loader now. So we will write a variable called train data loader. So train data loader, it will be equal, will create data loader from the torch library. So we'll use the torch dot utils, and then we will use the data, and then I think we will use the data loader, data loader. So torch utils data loader, and in this one we need to pass the train data, that this is the data for which we want to create the label. So since it is a data loader, so we need to tell the batch, that's why we have passed here batch size. So we need to tell that how many images you want to load at one time. So we'll create a batch size is equal to batch size. So now it will take 60, it will create a loader for 64 batches. So once we run this, the 64 images will be available for us. And then you can pass this shuffle is equal to true. Shuffle is equal to true because if we load the images, then there are high chances that the images are the similar images are in one batch, so that we don't want. So we shuffle so that there is a high probability that the one batch consists of images of all of the 10 classes. So that's why we are doing this shuffle. Okay, so that's what about the train loader. And then what we can do is we can just copy this one and paste it here, and then we can create a test loader, test data loader. We can set this is the test data, batch size is same, shuffle is equal to true. Yeah, that's also. Sometimes people may want to increase the test data in batch size for the test data sets. Reason is that in the testing we are not computing the gradients, we are not, so our model parameters are not that heavy. So for test we can still increase the size. Okay, but for the time being we'll just keep this as it is. Okay, so run this one. So once we run this one, create loader, then we need to return also. So what we can do is return train data loader as well as the test data loader. And what we can do is we can save these data loaders here. To run this one, this one. Okay, so this is what we have now, the train data loader and test data loader. In case you want to see whether the how much is the how many data sets images are there, so you can all do here. So just say that I want to see print length of train data loader. So this is the length of train data loader, and then you can say that I want to see length of test data loader. Let's run this and it will show you 930 and 157. The reason this is showing is because this is 938 batches. So we have this 60,000 and then divided by 64 is the 937. So that is why it has the 938 batches. And similarly for the test dataset we have 10,000 examples, so we have 157 images. Now our next task is to display some image from maybe train loader or test data loader. So for that what we can do is we need to write a function here called maybe show sample. So this show sample will take data loader. So this data loader may be train or maybe test, whatever you want to pass. So it will take show sample, and what it will do is this data loader, if you will see here that if in case we want to just print what is the data loader, if I print this train data loader, so it says that this is a data loader. You can't see anything here. So this is a data loader. So in order to see the images into this one, so there are two ways to do this. So maybe one thing is that you can say for data in data loader and print the data. And then I'm saying a break. Okay, you can see some data coming from this one. So with this one you can do that, or you can say the length of the data. The length of the data is 2, and then in these two, if you want to see what is data 1, we'll say print data 0, and I'll show you the shape actually. This is an array, and so we'll say so this is a tensor of 64 images as we have done the batch size. So at the 0th place, so this train data loader consists of a tuple, and this tuple contains at the 0th place it's the images, and if you will see for the second parameter for this one, which is the data 1 at the first index, so this is the 64. These are the 64 labels, and we'll use this concept in the show sample. We'll display the label also. The other method is that we'll use it here in the show sample. Instead of using this loop and doing break, so you can create an iterator for this one, for the data loader. So you can create an iterator, and then you can call the next method. So whenever you call the next method, it will give you the next batch. So right now, for example, if you continue this one, so this is the first batch, we did break, but it will go up to 938 times because there are 938 batches in this one. So next will give us the same thing, but without doing any break. Okay, without any looping. So, and this next will give us again this, for example, this data contains or consists of 0 and 1. So this will also give us same thing, that it is data 0, which is the set of images, and data 1, which is the set of labels. So what I can do is I can store this x and y in the here. So this next will give us a tuple and can be stored in x and y. So now if you run this one and say that what is the shape of the x, print x dot shape, and then you will say the print y dot shape, and then let's say I'm using this show sample for the train data loader. Okay, so it will give you the, it's giving the same thing, that it's 64 120 28 and 64 is the label. So this is what it gives. So now if you want to display the images, so we want, well, let's say we want to display only one image, maybe the 0th image from this data set of the 64. So this our image is this one, image is equal to x at the 0th position. So this is our image, that this is what we want to display, and its corresponding label is equal to y0. I can just say label. Okay, so this is the label. So 0th image we have stored in the image, and 0th label we have stored in the label function. Okay, so now if we want to see the shape of this one, print image to shape. Earlier it was 64 120 28. Now it will be 128 128 only, because 64 we have already sliced there. We have done now the 0th index. Okay, so now we have 128. So if we want to use the PyTorch, the matplotlib function to display this, so it doesn't need this one dimension. It just need 28 by 28 pixels only, because it's a grayscale image. We don't need the third dimension only. If it's a colored image, then definitely we need the color dimension, channel dimension also. But for grayscale, channel dimension is not required. Okay, so in order to reduce this, we can just unsqueeze the image. So we can call it here that image is equal to image dot squeeze. Okay, so let's run this one. So now it's good. It's now 28 by 28. Okay, and if we see the label now, let's print the label also. Print label. So if we print the label here, this is tensor 4. Okay, so we know that this is a tensor 4, and fourth means that we can find out that where is the fourth. This is a quote. Okay, so we know this is the exact label of this is the quote. Okay, so this is a scalar quantity. So what you can do is you can just call the method called item, and you can change this one. So we have transformed the images to its tensor that we need for the display purpose, and the label needs to be removed. We need to convert this to a scalar quantity, and from the torch to scalar. Okay, so what we want to do is we will say the label dot item. So if it says one-dimensional tensor, you can just call the item and it will convert to a scalar. Okay, so it gets changed every time you will do. It may change. Why? Because because of the next. So every time it is giving you the next batch. So whenever you call the next, it will give you the second batch and third batch and fourth batch. So not like that break that it will always give you the first batch. Okay, so that's why every time you will do this, then because these images are also getting changed, we can't see this shape only, but we will see soon. Okay, so this is the label 5. So we got the label 5, and now if you want the actual label, so what you can do is the label is equal to, you can just pass this index to the labels, and say label. Okay, so now the label is press, now the label is center. Okay, so these are the labels. Now our next task is just to show this image. So we already have this image, which is the image dot shape. We have already converted this image. So here now we are ready. We don't want to now print these labels. Okay, so in order to display the image, we can just call the plot dot show, plot dot show, and then we can just pass the image here. Okay, and we can give the title, the plot dot title is what? Label. Okay, so this is the sender. You can see, and this is looks like colored image, but what reason is that we need to want to give them the color map also, that we want to tell that this is a grayscale image. So this is C map is equal to gray. Okay, so this is every time you run, you will get a different image. Okay, and let's say now. Okay, so this is the image from the trained data loader. Similarly, we can display the images from the tested data loader. Okay, so you'll see here that it shows only one image, although we call 2 times. The reason is that image is getting overridden. So what we can do here is we can call this as a plot.show. So what happens is once you call it will show, and the second time again it will show. So both the images will be available here. So this is a shirt from the train data loader, and this is a t-shirt and top from the test data loader. And every time you run, you will get two images, maybe from the different batches. Okay, so this was all about our first part. We were able to download dataset. In this case, we have downloaded the FashionMNIST, but you can download any dataset from the Torch Vision library. We have created a data loader. We have developed a data loader for FashionMNIST, but you can create data loader for any of the function, any of the dataset that's available there. Okay, and in future lesson we'll do how to customize this data loader. Maybe the images are into your folder or into your home directory, and then how to get those images and use those images using the customized data loader. We'll see that. And then how to show the sample images. This pretty much will be useful in all of the projects where you have the data loader and you can just call the show sample. This is to help that everything that we have downloaded, we are able to access it, so that there is no problem during the training. Okay, so we'll meet in the second video for the second part, where we will do the neural network, create a neural network. Okay, thank you.